Imagine for a second that you're a manager, right? And you just hired this team of incredibly smart, incredibly fast experts.
Like absolute world-class talent.
Exactly, world class. But there's a huge catch. These experts have literal amnesia every single time you hand them a new assignment.
Total blank slate.
Yeah. They remember absolutely nothing about what you discussed like 5 minutes ago. They don't know who else is on the team or even what the overarching project is.
Unless you explicitly write it all down for them right then and there.
Right. So how do you get that specific team to build a comprehensive, multi-layered investor report without the entire project just completely falling apart?
I mean, in the real world, if
Yeah.
you hired that team, you'd be looking at a total management nightmare.
Oh, you'd spend your entire week just repeating yourself.
Exactly. But in the world of artificial intelligence, that exact setup, brilliant, isolated, amnesiac workers, is actually the gold standard for getting complex things done.
It's wild. And that's exactly what we're getting into today. Welcome to today's deep dive. We are unpacking this really fascinating architectural certification guide for Claude.
Specifically, we're looking at domain 1.2, which is multi-agent orchestration.
Right. And our mission today is to figure out how developers are actually building these production-grade systems. Because we are moving way beyond the idea of just, typing a question into a single chat box.
Oh, way beyond. We're looking at systems where a central AI acts as a literal manager, delegating tasks to specialized subagents to achieve massive multi-step goals.
And the really cool takeaway here for you listening is that the lessons on how to orchestrate these amnesiac AI agents, they apply just as much to structuring a Python application as they do to leading a real human team.
Yeah, that structural element is really the key. I mean, as AI capabilities have surged lately, we've found that the bottleneck isn't usually the intelligence of the model itself.
Right, the models are smart enough.
Exactly. The breaking point is the architecture. It's how you actually structure the communication and the delegation.
Because if you just throw a massively complex task at a single prompt, or even toss it to a messy group of unstructured agents.
This system just collapses under its own weight. Every time.
So to build a functional system of experts, you first need a master coordinator. And the certification guide refers to this as the hub-and-spoke mental model.
Right, so the coordinator is the hub, and the subagents are the spokes.
And according to the source material, this coordinator is strictly limited to doing only 3 things. It decomposes the user's overarching goal, it delegates those broken down pieces to the spokes, and finally, it synthesizes the returning results.
That's it. It never, ever actually executes the ground-level tasks itself.
I always picture this like a general contractor building a custom house.
Well, that's a great way to look at it.
Right, because the general contractor, the coordinator, understands the blueprint. They know exactly when the foundation needs to be poured, when the roof needs to go on.
But the second that general contractor puts down the clipboard, picks up a pipe wrench, and starts doing the plumbing themselves,
the whole management structure just falls apart.
Exactly.
They completely lose sight of the big picture because, well, their head is stuck under a sink.
Right. And the exam guy actually points out that a massive trap for developers is giving the coordinator those ground-level tools. They call them leaf tools in the documentation.
Like giving it the search web tool or a read-document tool?
Exactly. If you give the coordinator the search web tool, it will inevitably try to do the research itself instead of delegating it to a specialist. It just can't help itself.
So how do you actually enforce that boundary in the code?
Well, the mechanism that actually enforces this discipline is a very specific tool called the task tool.
Okay, the task tool.
Yeah. For the coordinator to be able to spawn these specialized subagents, the task tool must be explicitly listed in its allowedTools configuration.
So without that specific tool, the hub basically can't build any spokes.
Exactly. But the real elegance of this design shines in what is withheld. The subagents do not get the task tool.
Oh, wow.
Yeah, they cannot spawn their own subagents unless they are specifically designated as middle management, which is a concept called nested orchestration. We might touch on that later.
Right, so the coordinator essentially says, I need to use the task tool to manufacture a research agent, and it hands over the instructions for that one specific job.
And because of that strict boundary, the subagent's internal workflow remains entirely invisible to the coordinator.
Wait, entirely invisible?
Totally. Let's say a subagent is tasked with finding a specific financial metric. We call its internal process an agentic loop.
Okay, so what does that loop actually look like?
Well, it might run a web search, get back some useless junk, realize that search term was bad, formulate a new query.
To the paywall, back up, try a third time.
Exactly. That incredibly messy trial and error process that is the agentic loop. And the coordinator sees absolutely none of it.
So it doesn't have to manage all those failures and retries?
Not at all. It simply waits. And eventually it receives a clean, finished tool result block containing only the final data. It keeps the central nervous system of the application incredibly lean.
That makes a lot of sense. But because the coordinator is completely blind to that messy internal loop, the next logical hurdle is, well, figuring out how to communicate with these subagents in the first place.
Right, the communication protocol.
Yeah. Once our general contractor knows how to delegate using that task tool, what exactly do they tell the workers?
This is where we get into the concept of context isolation.
Right, the amnesia part. The source outlines that every single subagent starts with a completely fresh, empty message history. They have zero context.
Not at all.
They can't see the user's original request, they can't see the coordinator's master plan, and they definitely have no idea what the other subagents are doing.
They are your brilliant amnesiacs functioning entirely in a vacuum.
Okay, wait, I actually have to push back on this.
Sure, go ahead.
If I'm managing a human team, keeping them completely in the dark is just a terrible strategy.
From a human management perspective, yeah, usually.
Right. People need the big picture to feel invested, to understand the stakes, and to make smart judgment calls when things inevitably go wrong. Why are we treating AI agents like these isolated drones?
It's a really natural assumption to make.
Shouldn't we give them all the background history and the coordinator's thought process so they can, make better decisions?
We constantly anthropomorphize AI. We compare it to managing humans. But in multi-agent orchestration, sharing that big picture leads to what the guide calls the context pollution anti-pattern.
Context pollution.
Yeah. Taking the coordinator's full message history and passing a copy of it down to every subagent is generally an absolute disaster for the system.
Why, though? Why does that break this system?
There are three main reasons, starting with anchoring bias.
Okay, anchoring bias.
If a subagent sees the coordinator's preliminary reasoning, or it sees intermediate results from some other subagent, it tends to just agree with those prior conclusions.
Rather than doing its own independent analysis.
Exactly.
Yeah.
If the coordinator's notes say, I suspect Q3 revenue is down, the subagent will subconsciously look for data that confirms revenue is down. It anchors to the existing narrative.
Well, that defeats the whole purpose of hiring an independent expert in the first place.
It really does.
The second issue is scope creep.
Oh, I've experienced this.
Have you ever asked an AI to, say, fix a small typo in a block of code, and it decided to helpfully rewrite your entire application?
Yes. It's infuriating.
That is scope creep. If a subagent hired strictly to look at financial anomalies suddenly sees this whole conversation about marketing strategy in the history.
It might try to weigh in on the marketing.
Exactly.
So it's like the plumber sees the electrical plans sitting on the kitchen counter and just decides to start rewiring the house.
Which completely throws off the entire project timeline. And then there's a third reason, which honestly is perhaps the most critical for production systems.
Let me guess. Cost.
A massive cost explosion.
Yeah. For those listening who aren't writing API calls every single day, think of a token as roughly 3/4 of a word.
Okay.
Every single token of context you pass to an AI costs you fractions of a cent. So if you have 5 subagents and you pass them a 3,000 token history of the coordinator's rambling thought process.
Oh, wow. So you are paying for 15,000 completely unnecessary extra input tokens for every single orchestration run.
Exactly. Not to mention, AI models have a limited context window, a maximum amount of text they can physically remember at once.
Right.
If you stuff that window full of irrelevant history, the AI might actually forget its primary instructions or just truncate its output mid-sentence.
Okay, so dumping the whole history is clearly out. But if these agents have total amnesia and zero context, how do they actually know what to do without failing?
The solution is that prompts must be explicitly and selectively packaged by the coordinator.
Carefully curated, basically.
Right. The coordinator has to build a complete, self-contained little world for that specific subagent. The prompt has to explicitly contain the task, the user's ultimate goal, the specific scope of the agent's work, the constraints they absolutely must follow, and any relevant input data.
The subagent receives exactly what it needs to execute its specific job and literally nothing more.
Nothing more.
Because the certification guide really highlights the danger of getting this wrong. They call it the missing explicit context anti-pattern.
It's a very common mistake.
Right. If you forget this amnesia rule and just toss a subagent a vague prompt like, hey, analyze the situation and provide insights, or write up the section we just discussed, it fails miserably.
Because in the subagent's isolated little bubble, there was no we.
Right.
It wasn't part of any earlier discussion.
And what the guide explains is that the AI will usually do one of two things in that scenario.
Either of which are good.
Nope. It might return a useless, generic non-answer like, I would need more information about the situation to provide insights.
Which completely ruins the coordinator's final synthesis because it has no data to work with.
Exactly. Or, and this is much worse, it will confidently hallucinate an answer.
Oh, yeah.
Because large language models are fundamentally prediction engines, right? If they don't have the context, they will just predict what a plausible answer might look like.
It will invent a highly convincing financial analysis completely out of thin air, pass it back, and the coordinator will just blindly synthesize that lie into the final report.
Which brings us to arguably the most strategic part of the architecture, because these agents are trapped in these isolated bubbles, only knowing what they're told.
The entire success of the project now hinges on one single thing.
How the coordinator slices up the overarching project.
Decomposition. It is the single most critical step in the entire process.
The guide spends a lot of time on the danger of micromanagement here. It details an anti-pattern called narrow decomposition.
Yeah, let's walk through an example of that.
Okay, let's say a user wants a comprehensive due diligence report on a tech company. A poorly designed coordinator might break that massive request down into 12 atomic microscopic tasks.
Like task 1, find the CEO's name. Task 2, find the founding year. Task 3, find Q1 revenue.
Right. And that hyper-segmented approach just creates massive, invisible coverage gaps.
Huge gaps.
It makes me think of a jigsaw puzzle. Imagine taking a 1,000-piece puzzle and handing one single piece to 12 different people.
Okay, I like this.
And you tell each of them, hey, describe this specific piece to me. So one person says, well, mine has a little bit of blue on the edge. Another says, mine is straight on one side with a red dot.
But none of them are actually looking at the picture on the box.
Exactly. They have no idea it's a picture of a sailboat. So when they hand their descriptions back to you, you just have this disjointed list of colors and shapes. You completely miss the narrative that connects the pieces together.
That is a perfect analogy. In the guide's example, if you ask one agent strictly for Q1 revenue and another strictly for the CEO's name, nobody's looking at Q2, Q3, or Q4.
Right.
And more importantly, nobody is analyzing the strategic direction, the market position, or the emerging risks. The connective tissue between those narrow tasks is exactly where the actual value of an analysis lives.
And crucially, the coordinator cannot magically fill those gaps at the end during synthesis time.
No, the coordinator only knows what the subagents return. If nobody was explicitly assigned to research the market risks, the final synthesized report will simply have zero risk analysis whatsoever.
Okay, so if atomic micromanagement ruins the final product, what is the correct way to decompose a project so the AI actually provides deep, meaningful insight?
The recommended approach is called balanced thematic decomposition.
Thematic.
Right. Instead of 12 agents hunting for individual disconnected facts, you want to design a system with maybe 3 to 5 agents that own entire conceptual themes.
So instead of a prompt saying, hey, find Q1 revenue, the prompt says, you are the finance agent. Your theme is the full financial performance for the years 2023 and 2024.
Exactly. One agent owns the complete financial picture. All the quarterly revenues, year-over-year growth, profit margins, cash burn rate.
And then another agent owns like products, technology, and competitive market position.
And maybe a third agent owns recent news, executive changes, and potential liabilities.
So each agent is given a meaningful slice of the pie.
Right. They have enough broad scope to actually perform analysis and identify trends within their assigned theme. And that drastically minimizes the gaps between them.
Okay, so we have our hub and spoke set up. We have our amnesiac experts perfectly isolated so they don't get distracted by scope creep. And we've given them broad thematic assignments so we don't lose the overarching narrative.
Right.
But now we have 3 or 4 specialized subagents ready to do heavy, time-consuming research. How do we run them without the user just sitting around all day staring at a loading screen?
This is where we get into the actual performance engine of the architecture, parallel execution.
The guide flags this as a really critical concept for anyone taking the certification exam. How the coordinator issues these task calls basically changes everything about how fast the system feels to the end user.
Completely changes it. To run agents in parallel, the coordinator must issue multiple task tool calls in a single response.
Let's look at the alternative just to understand why this matters so much.
Sure. If a coordinator decides to do things sequentially, saying, first, I'll use the cast tool to spawn the research agent, waits for it to completely finish, and then says, okay, now I'll spawn the analysis agent. It wastes a tremendous amount of time.
So if the research agent takes 8 seconds to run its loop, the analysis agent takes 6 seconds, and the writing agent takes 5 seconds, a sequential run forces the user to wait a total of 19 seconds.
You're basically just waiting in a single file line.
But if the coordinator system prompt explicitly instructs it to issue all of those task calls simultaneously in one single response array, the underlying code changes how it handles them.
Right. For the non-coders listening, the guide mentions something called a thread pool executor in Python.
Okay, wrap your head around this. Think of that like a grocery store manager seeing a huge line and deciding to open up 4 checkout lanes at the exact same time instead of forcing everyone through just one.
Exactly. And that parallel processing is only possible because, under thematic decomposition, the agents don't actually depend on each other.
Ah, right. The finance agent doesn't need to wait for the news agent to finish its job before it can start pulling revenue numbers.
Precisely. They achieve true concurrency. And when they run in parallel, the total execution time is really only as long as the single slowest agent.
So instead of a 19-second wait, the whole orchestration takes maybe just those 8 seconds.
You basically cut the latency in half, which is massive for user experience.
Hold on, though. Let me reason through a specific scenario here.
Sure, what's the scenario?
The task tool parallel execution makes perfect sense for dividing up distinct separate themes like finance and marketing. But what if I want the AI to brainstorm? Let's say I want it to write 3 completely different strategic approaches to the exact same 50-page financial document.
Okay.
So maybe I want a highly conservative analysis, an aggressive bullish analysis, and a worst-case risk analysis. If I use the task tool, which we established gives each agent a completely blank slate,
Yep.
do I have to spend the token cost to feed that massive 50-page document into 3 separate amnesiac bubbles? Because that feels incredibly inefficient and honestly really expensive.
You've hit on a fundamental architectural limitation there. And the answer is no, you would not use the task tool for that brainstorming scenario.
Okay, good.
The guide draws a very sharp contrast between the task tool and a different capability called fork session.
Fork session?
Yeah.
How does a fork session solve the memory problem?
Well, we established that the task tool spawns a subagent with a fresh, empty context.
Right.
Fork session, on the other hand, creates a branched clone of the current session exactly as it exists at that specific moment in time.
Oh. I picture that kind of like saving a video game right before a big boss fight.
That's a great way to think about it.
You have all your inventory, all your health, and all the history of the game up to that point. And you can spawn 3 different timelines from that exact same save state to try out different strategies.
And if you die in one timeline, it doesn't ruin your main save file.
Exactly.
That is a perfect way to visualize it. Fork session takes the full parent context, including that massive 50-page financial document you already paid tokens to process, and clones it.
So it's built specifically for exploring parallel alternative approaches.
Exactly, like your ABC testing of the strategic analysis. All 3 branches need that massive amount of shared research context, so you fork the session 3 times.
The conservative branch, the bullish branch, and the worst-case branch all start from the exact same shared knowledge base.
But then their subsequent reasoning evolves completely independently.
So they don't pollute each other's thought processes. Like, the bullish branch doesn't suddenly start hedging its bets just because the worst-case branch is writing terrifying predictions next door.
Right. They run in parallel, totally isolated from one another after the fork, and the main parent session stays completely clean of all their internal drafting.
It just looks at the 3 finished analyses, picks the best one, the winner, and moves the main workflow forward.
You use fork session when you want to explore mutually exclusive alternatives from a shared starting point.
And you use the task tool when you want to delegate discrete, complementary subtasks that will eventually all be stitched together into one larger product.
You nailed it.
Synthesizing all of this for you, the listener, whether you are writing Claude API scripts or managing a marketing department, the principles of effective orchestration are remarkably similar.
They really are.
To build a highly functional system of experts, you need a clear hub-and-spoke boundary. The manager coordinates, the workers execute.
You need balanced thematic delegation.
Right, giving agents a comprehensive theme to own rather than a microscopic atomic task so you don't lose the overarching narrative.
You need strict context isolation to prevent distraction, anchoring bias, and scope creep.
And you need parallel execution so your users aren't needlessly waiting in line.
When you combine all those architectural principles, the efficiency you achieve is just staggering. The certification guide actually provides a mathematical formula based on an execution trace of a complex research task.
Oh, right, the formula.
It describes the growth of the coordinator's message history using the formula 1 plus 2n.
Let's break down how that math actually saves the system from crashing.
Sure, so in that formula, n represents the number of delegation rounds.
Okay, so if I launch 4 complex subagents in parallel, is that 4 rounds?
No, that's the beauty of it. Because they are parallel, that counts as just one single delegation round.
Uh,
So the math is 1 plus 2 times 1, which equals 3. Despite coordinating 4 separate, highly complex research agents that might have spent hundreds of tokens failing and retrying searches in their own agentic loops, the coordinator's internal message array only grows by 3 entries.
Let me see if I have this right. It logs the user's initial prompt. That's 1.
Right.
The single response where it dispatched all 4 tasks simultaneously, that's 2.
Yep.
And the single bundled message returning all 4 clean results, that's 3.
Exactly. That is why the context window doesn't crash. The massive, messy reasoning of the subagents is entirely hidden.
The system scales beautifully without blowing up your API costs or confusing the coordinator with pages of irrelevant search history.
It's incredibly elegant.
It really is. Now, I want to leave you with a provocative thought that builds on something mentioned briefly in the guide earlier. You brought it ested orchestration.
Right, the idea of level 1, level 2, and level 3 agents.
Think about the broader implications of this architecture. If a coordinator can use the task tool to spawn subagents,
And developers decide to give some of those subagents the task tool so they can spawn their own subagents.
we are looking at the birth of autonomous fractal AI corporations.
Oh, absolutely. You are basically watching an entire organizational chart assemble itself dynamically in milliseconds,
A CEO agent analyzes a goal and spawns VP agents,
who in turn spawn director agents.
who finally spawn the leaf-level worker agents to execute the actual web searches.
And because of the ironclad rule of context isolation, the top-level hub has absolutely zero visibility into what those microscopic leaf agents are actually doing down there.
It only sees the synthesized summaries pass back up the chain. So how far down that rabbit hole can delegation go before the top-level hub fundamentally loses understanding of how its own objectives are actually being achieved?
That's the big question. It becomes the ultimate black box of middle management operating at machine speed.
I highly suggest you mull that over the next time you casually ask an AI for a simple favor. Behind the scenes, you might just be waking up a sprawling corporate hierarchy of amnesiac experts furiously delegating tasks in the dark, all while entirely invisible to you.